This is a general overview of the HVE-CSI software. HVE-CSI is a computer environment for studying interactions between vehicles and the environment. HVE stands for Human Vehicle Environment, the three factors which influence a crash. HVE-CSI allows the crash site investigator to create models of vehicles and environments and use the EDCRASH and EDSMAC physics models to reconstruct and simulate motor vehicle crashes. The HVE-CSI program window includes a menu bar, time-saving toolbars, an event and playback controller, along with thumb wheel and other viewer controls. The HVE-CSI menu bar allows the user to select from File, Edit, View, Mode, Setup options, and Help menus to access important user information and options. The toolbars provide quick and easy access to commonly used features, and the integrated drop-down lists explain or adjust the current viewer selections. The event controller provides easy access to control the display of results of the event calculations. The buttons allow you to reset the calculation model for recomputation, or play, pause, rewind, reverse, or advance to the end of the results. The event controller also displays the current simulation time and other important time-related parameters. The viewer controls, and also the thumb wheels, allow you to adjust the current camera view and also decide if the camera is fixed to a point on the environment or attached to a moving vehicle. Using HVE-CSI involves four essential modes. The vehicle mode to select and edit all of the vehicles involved in your case. The environment mode to select and create the environment involved in your case. The event mode to set up and execute reconstruction and simulation models which analyze the interactions between the vehicles and the environment. And the playback mode to create alphanumeric and graphic reports, as well as simulation video output to document and present your work. Let's walk through an example and take a closer look. Vehicles are created and edited using the vehicle editor. To create a vehicle, we would click on the Add New Object button on the toolbar to display the vehicle wizard. We would choose our vehicle according to vehicle type and class category. We would edit the basic dimensional and inertial properties of the vehicle. We would edit the name of the vehicle, and by pressing OK, the selected vehicle is now displayed in the vehicle viewer. At this point, you may choose to edit additional vehicle properties such as color, inertias, tire friction, or stiffnesses by clicking on the vehicle's CG, tires, steering wheel, or exterior icons. For example, by clicking on the CG and selecting color, we can change the vehicle's color to red. To add an additional vehicle to your case file, simply repeat the steps. Let's add an additional vehicle, this time a yellow sport utility vehicle. There, our vehicles are ready. Now let's work on our environment. Displaying your crash site image as the environment for your work is optional, but is highly recommended. You can display aerial photos, such as a Google Earth map or an image from your drawing program that includes crash site evidence. To add our environment, click on the Add New Object button on the toolbar. Choose Open to load an aerial photo of your crash site. The file selection dialog includes an option list that allows us to select the format of the file, and then also the desired file itself. We then are prompted to match the scale of the image to that of our vehicles by identifying the coordinate location of the upper left and lower right corners of the image. If we accept the settings, the environment will appear in the viewer. Here now is a Google Earth map of an intersection where a crash occurred. This image has been edited to display evidence collected at the crash site, including skid marks from the vehicles. We have our vehicles in the environment for our case, and we are now ready to perform a reconstruction or simulation of the crash. The event editor is displaying an existing event, which we will use for our presentation. The event editor is used to reconstruct and/or simulate collisions between any of the vehicles in the active case file. An event is defined by selecting one or more of the vehicles and then the EDCRASH or EDSMAC simulation model. To create an event, we would click on the Add New Object button on the toolbar. We would then edit the name of the event. We would then select the vehicles involved in our study, and then we would select the calculation method. EDCRASH is a reconstruction type model. A reconstruction is the determination of initial conditions, usually impact speed, based on post-accident evidence. EDCRASH can perform a momentum and/or a damage-based analysis depending upon your inputs. The reconstruction calculations typically provide results such as velocity at impact and the delta V, energy absorbed, and PDOF during impact. EDSMAC is a simulation type model. A simulation is the prediction of vehicle paths and damage based upon initial conditions, typically position and velocity. The simulation calculations typically provide results such as kinematics, kinetics, and tire forces. The calculation method you choose depends upon the needs of your case. Normally, the EDCRASH reconstruction model is executed first because it provides part or all of the initial conditions required to execute the EDSMAC simulation. Let's go ahead and cancel out of this dialog so we can take a closer look at the existing EDCRASH event and learn what steps are required to complete a reconstruction. Event setup involves using the setup menu to complete steps for each vehicle to assign the required positions, the desired driver controls, and any damage profile data. Every simulation or reconstruction requires positioning of vehicles within the environment. EDCRASH requires at least impact and rest or final positions to be assigned, such as shown in the path location box in the position velocity dialog. HVE-CSI allows the user to position vehicles within the environment using direct manipulation or by entering coordinates in the position velocity dialog itself. To use direct manipulation, we can click on a vehicle within the event viewer, then we can drag and drop it using the crosshairs centered on the vehicle CG. By clicking and holding the crosshairs, we can drag it left or right, up and down, and if we click on the ring around the vehicle, that's the yaw manipulator that will then change the orientation or heading angle. If we know the exact coordinates based upon measurements from the site, then we can enter those directly in the position to velocity dialog itself. For EDCRASH, the vehicle model is controlled by driver inputs. To supply a vehicle's driver controls, you must first select a vehicle from the list, then go into the Setup menu and choose Driver Controls. The Wheel Data dialog is used to enter the wheel lockup and steer angle for each wheel on the selected vehicle. It differs from other driver control tables that we will see later in that its values are constant rather than time dependent, because EDCRASH reconstructions do not calculate in the time domain. For EDCRASH, you can also assign a damage profile to the vehicle in order to perform a damage-based analysis. To supply a damage profile, first select a vehicle, then choose Damage Profile from the Setup menu. The damage profile defines the location and character of vehicle damage by allowing the users to specify the width of the damage, the depth of crush at up to 10 equally spaced intervals along the damage width, the location of the center of damage relative to the vehicle's CG, and also the principal direction of force, or PDOF. The damage data dialog uses the damage profile and stiffness coefficients to calculate a delta V, damage energy, and peak force as if this vehicle had been in an impact with a non-deformable fixed barrier. EDCRASH will combine the damage information supplied for both vehicles into the output results for the vehicle-to-vehicle collision calculations. Before we run the calculations, however, let's take a look at a couple of useful display options in HVE-CSI. The available display options are Key Results for displaying the current calculation results for each vehicle, Coordinate Axes to show the coordinate axis system on each vehicle, Velocity Vectors to display the current direction of each vehicle's velocity vector. We also have the ability to show skid marks, display tire tracks, show targets that are positioned in the environment. There's also a distance tool that allows you to measure between selected points. And then also additional user options include the ability to select your program units, change render settings and playback settings, adjust your simulation controls and calculation options, as well as specify user preferences. Our event has actually been set up and our settings are where we want them to be so we can see results, so let's go ahead and run the event. For EDCRASH, this will mean that using the measured path positions and damage profiles, the program will estimate the initial velocities and velocity changes. Use the event controller and press play to execute the calculations. The key result windows now display values for impact velocities, delta V, and other important results. We'll take a closer look at the output reports from EDCRASH in just a minute, but first let's walk through the procedures to run an EDSMAC event while we're still in event mode. To execute a simulation program in the event editor, you normally provide vehicle initial conditions and driver inputs. The EDSMAC event setup involves assigning the required positions and velocities for each vehicle and also assigning the desired driver controls. Once again, HVE-CSI allows the user to position vehicles within the environment using direct manipulation of the vehicle by dragging and rotating, or by entering position coordinates in the position velocity dialog. For an EDSMAC simulation, driver controls available are: the steer table allows you to provide steer angles at each steerable axle. The brake table allows you to provide longitudinal braking force at each wheel. And the throttle table allows you to provide tractive effort at each drive wheel. After an event has been set up, it is ready for execution. For simulation models, this means starting the simulation and watching the event viewer to study the interactions between the vehicles as they move to their rest positions. The goal is to match the simulated trajectories and damage profiles with the measured trajectories and damage. Now let's run the EDSMAC event by pressing play to start the simulation calculations, and then we'll take a closer look at the output reports for both our EDCRASH and EDSMAC runs in playback mode. The playback editor is used to create output reports. Unlike the other editors, the playback editor may display multiple viewers, called report windows, each containing different output results for a particular event. These results may be numeric and graphic reports, trajectory simulations, and variable output tables. The playback editor also provides the ability to create a simulation movie. To create a report, we would click on the Add New Object to display the report window dialog containing a list of all the executed events in our case. We would choose an event, and then select the desired output report. Output reports for EDCRASH include accident history, damage data, damage profiles, event data, messages, momentum diagram for damage, momentum diagram for scene information, program data, references, site drawing, and vehicle data. Output reports for an EDSMAC simulation include accident history, damage data, damage profiles, messages, program data, references, trajectory simulation, variable output, and vehicle data. Several sample reports are displayed around the screen, such as the accident history based upon EDCRASH for speed determination, damage data from the EDSMAC collision simulation, as well as a trajectory simulation from our EDSMAC simulation as well. An additional viewer is also available in this mode, and it's called the playback window. This window allows the user to create compressed movie file in AVI format. To use the playback window, you create one or more trajectory simulations, then add the window using the Options menu on the toolbar. Adjust the viewer settings to where you want the desired camera appearance, set the destination as AVI, adjust your render settings, and the movie will be recorded as it is played in the viewer. You can play this movie back within the same viewer, or you can view it separately in any AVI player or insert it back into your PowerPoint presentations. This sample walkthrough has shown you the basic functionality of HVE-CSI that will help you reconstruct motor vehicle crashes. For further assistance, please refer to the tutorials or contact us with your questions. Thank you for your time.